So today's keynote, we have a very special keynote, a gentleman who has been here, not to Budapest, but to Connect before, and is always an interesting speaker. Please join me in welcoming John Corbet.
All right, well, good morning, everybody. Thanks for coming out early on a Friday morning. It's nice to be here in Budapest, where I've never been before. So, unfortunately, I come bearing some bad news of a sort. We had a bit of a discussion on the Linux kernel mailing list. People got upset with Linus Torvalds because patches were being dropped and the process wasn't working very well. It ended up with him complaining that everybody was just adding pressure to him and telling them, go away, people, don't CC me anymore, I'm not interested, I'm taking a vacation, don't talk to me anymore about this. Okay, the good news is that this happened about 19 years ago, and so he's come back since then. But this was not the first, but one of the first and biggest of episodes that we've had over the years in what I call development process scalability. The Linux kernel is famously scalable and it runs in everything from these tiny little boards that we saw up here up to the largest of computers. Over the years, we've had to scale the development process in the same way, going from a project that was initially a hobby done by a single developer up to what we have now, which is rather larger than that. Over the years, the scaling has brought about some challenges of its own. And what I want to do is to talk about some of those and the ones that I think we may be facing in the future. So we got over that episode in 1998, figured out how to go on, but we had other issues as well. So if we think back to the early 2.x days, right, the 2.0 kernel came out at the beginning of 1999. The 2.4 kernel, which was the next stable release, right, the next feature release that we had, was 2 years after that. It took us 2 full years to do that. And then 2.6 came out actually 3 full years after that. So if you were waiting for a new kernel with new code, new features, new hardware support, you were waiting up to 3 years to get it. This was a fairly long period of time, especially in this period when Linux was just really beginning to be taken seriously, was just beginning to take off commercially. But we had an awful lot of gaps to fill still. We were still working very hard just to be competitive with proprietary Unix in those days, much less to actually take the lead. So there was a lot of development going on. Development was happening at what we thought was a furious pace back then, relatively slow compared to what we have now. But this business of taking up to 3 years to get a kernel out had a bunch of consequences. Since everybody wanted the stuff that, for example, was being developed for 2.6, but they wanted it back 3 years earlier when it was developed, when we actually needed it. We had distributors backporting all that stuff into the 2.4 kernel and creating these incredible Frankenstein kernels that they would ship. These were kernels that were tested by nobody but the distributor, not tested by the community as a whole. These were kernels that had ABI differences between distributors. There were these really massive things. And then for extra fun, they threw in a bunch of out-of-tree code of their own. Some fun things. How many of you remember the Tux web server? A few of you. We actually had a web server in the kernel. Fortunately, we no longer have that. So this created a lot of pain, and when, for example, 2.6.0 finally came out, it created a different kind of pain when everybody had to move forward from these one-off Frankenstein kernels into 2.6 and drag forward all this out-of-tree code, and so on. So the upgrade process was also quite painful for a whole lot of reasons. So this seemed unsustainable. It seemed like a real process problem that we were taking so long to get the code out to our users and creating this whole ecosystem that required all this backporting and so on. So we made some changes. We adopted what we call the upstream first rule. This rule says that before you ship code to your customers, it needs to be in the mainline kernel, or at least on a plausible path towards getting there. The distributors at the time adopted this rule quite seriously, and it made a big difference in terms of the kernels that we shipped to our community. We adopted distributed source code control. In fact, the truth of the matter is that we adopted any source code control at all, which made a big difference. It's hard to think back to 15 years ago when our patch management system was Linus Torvalds' email inbox, and it worked just about as well as you might expect it to work. And we adopted what is the current release model, where instead of going 2 or 3 years between releases, we went to about 9 or 10 weeks between releases, getting code out to our users very quickly. This reduced the pressure to get changes into the kernel quickly before they were ready. It reduced the need to backport things and so on, and really made the whole process run a whole lot more smoothly. These changes and some others helped us to establish a model of development that we had been aiming at for quite some years. I remember talking to people way back in 1998 about trying to do this, where instead of having just Linus Torvalds managing all the patches going to the kernel, we set up a hierarchy. We have a whole bunch of contributors out there contributing patches to a set of maintainers, subsystem maintainers. These are people who are specialized in a particular part of the kernel, who understand it, who can review and judge those patches and incorporate them, feed them up the chain, possibly to other maintainers, and those finally get up to Linus Torvalds, who can merge them into the main line without having to pay specific attention to every single patch going into the kernel. This mode of operation increased our scalability in a whole lot of ways. It took a lot of the load off of Linus, of course, which is good. And it set things up so that these maintainers could work, for the most part, without stepping on each other's toes. Each could handle a piece of the problem, and it allowed us to ramp up our patch flow in a very big way. So what did all this do for us beyond that? I showed you the release schedule before of 2 to 3 years between kernels. Now we have something that looks like this. This is the release history for the last year. So we do, in fact, now have kernels coming out every 9 or 10 weeks, pretty much like clockwork, which is good. The change rate that we have now is something we could not have imagined back in the early 2. Whatever days, where we have at least 12,000 changes going into each mainline kernel release, often more. The 4.9 kernel was the busiest development cycle in the history of the kernel development project, with over 16,000 change sets being merged over a period of 10 weeks. So we have definitely scaled the process quite a bit. As we've done this, we're bringing in, oh yes, we had, another way of looking at this is about 80,000 changes over the course of 1 year from about 4,000 developers. The number of developers can be seen in this little plot here. The upper line is just the number of developers participating in every kernel development cycle. So we're up to sometimes over 1,700 developers contributing to a single development cycle of the Linux kernel. Lots of people. The bottom line here, the one that looks relatively flat, is the number of first-time developers, the number of people we see in each development cycle who've never contributed to the Linux kernel before. And that number stays about what it is. It seems to be a fundamental constant of Linux development, that every development cycle features the work of about 200 new developers. It doesn't seem to matter how busy it is, how long it takes. We get about 200 new people each time around. So to my mind, this is a picture of a relatively healthy development community, right? We have a lot of people participating. We have more people coming in. We have a nice flow of incoming developers, which you need to keep your project healthy. This is all good stuff. Things are going very well. Partly as a result of this and other things, the Linux kernel is everywhere, right? I don't have to tell you all this about this. We've been wildly successful. So one might summarize this as saying, we seem to be on a roll. We're doing pretty well. Linux is doing great. So why is it that I say I'm here with some potentially bad news? Why is it that I'm worried? Well, that's what I'm going to spend the rest of my time talking about. So let's go back to this picture of our development model. We tend to focus an awful lot on the developer side of the picture here. What we see on the left-hand side of the picture, I'm sorry, yeah, on the left-hand side of the picture. We work hard to bring more developers into our community, to recruit people, to teach them how to work with our process, and so on. In fact, there's a lot of stuff happening at this very event aimed at doing just that. Right? Linaro has done some very good work at bringing developers into our community. And this is good. We've needed this. We need to continue to do it. We need to recruit developers. I think that we have paid less attention to the middle piece of the puzzle and the maintainership aspect of how the Linux kernel works. And I think that that is where we are likely to see scalability problems showing up in the future. So all of this came to mind to me a couple of months ago as I was at another conference in Australia, wondering just what it was I was going to say to this crowd in Budapest in March. And I saw a talk by a lady named Nadia Iqbal. She was working in the finance industry, actually, not in the technology industry at all. And she put together this lengthy report called Roads and Bridges. It was all about all of the open source software that our economy depends on in general, and the rather parlous state of maintainership of much of that software. She wasn't really talking about the kernel. In fact, pretty much avoided it. Was talking about the much wider ecosystem and the fact that we're not really paying much attention to the needs of our maintainers. She was focused to a great extent on maintainers working on their own time and thus being unable to keep up with things, and that was leading to things like shell shock and heartbleed and other famous problems like that, where our important software is simply being neglected. But it goes beyond that. It's a good report. I would recommend searching it out and reading it if you're interested in this kind of stuff at all. So, as I said, much of her focus was on support for maintainers. This is the corporate support for subsystem maintainers in the Linux kernel over the course of the last year. These numbers are approximate, but it shows a few things. First, it shows that our support for maintainers is relatively concentrated. We have typically 200 or so companies supporting work in each development cycle. The number of companies that are willing to support subsystem maintainers is quite a bit smaller. We have a lot of companies who are happy to support someone to make their hardware work. Fewer who are interested in making the process as a whole work, but it's enough. One of the things that you can see there is about 4% of our maintainers, our subsystem maintainers, are working on our own time, which is pretty much in the noise. So we're good in this sense. We have good support for our maintainers. If you look at the support for the core kernel, it becomes more concentrated. There's fewer companies willing to work in that area to support the core that everybody depends on. But once again, that support is there. So support for maintainers as such is not our problem. But we do see even here the beginnings of one aspect of it, which is there are parts of this that nobody is willing to pay for. Certain parts of the common code that companies are less willing to support. This includes a certain amount of core kernel work. If you just think about things like, I don't know, fixing the CPU hot plug system, that sort of thing, work that the developers try to get support for years, and has only now succeeded in doing that. Documentation, of course, is a bit of a sore point of mine. Has often not been supported. How many of you like the kernel's configuration system? Wow. We have a couple masochists in the audience. Our configuration system is widely regarded as being painful and a mess and so on, but nobody, it's just barely supported, and nobody is really even thinking about replacing it with something that would work better, which is good because the last time somebody did try to replace it, it did not end well. Things like debloating, I was actually glad to hear from Nico that he's working on some tinification efforts. But in general, that's not something that we see supported. And it's actually important for scaling Linux down to the smallest of systems, which I think is still something that we want to work on to do. And one that I want to talk about just a little bit further, which is security. Because the kernel is at the core of all of our systems out there. If the kernel is not secure, our systems are not secure. And we see over and over again that security actually does matter to our users at pretty much every level. So given that, you would think that we would have, say, a security maintainer, but we don't. We have a maintainer who's in charge of keeping SE Linux working and so on. We have nobody whose job it is to make sure that the kernel itself is secure. Nobody. Right? We have no security officer. We have nobody who's watching for this. And as part of this, we have no training, no documentation. We have nothing for a developer who wants to learn how to write kernel code that is secure, that will not put vulnerabilities into the kernel. You would think that we would have this because there are a lot of things that are unique to kernel development in terms of security, a lot of pitfalls there that we don't have anywhere else. But we have nothing for people who want to learn about that. And I think this is a bit of a shortcoming. This is an area where our maintainer model has not really kept up with what we need to do. And there are consequences of this that are obvious. I would like to say that this is the list of CVE numbers of known vulnerabilities in the kernel for 2016. But the truth of the matter is I made this particular slide in September. And never saw the point in filling out the rest because, well, I didn't have room. And it gets the point across. The actual number of CVE entries is probably about double this for 2016, and we haven't found them all yet. Now, kernel development, due to its nature, is always going to have more vulnerabilities than other projects, just because of our rate of change and because the nature of the kernel's job makes it so that things that are just bugs in other systems become vulnerabilities in the kernel. But still, this is a lot. This is a lot of holes. This is not something that we should really be having in a core component of our system, especially in this day and age where we're becoming increasingly concerned about security. We have other sorts of problems as evidenced by this little patch here. This is a patch to this TCP protocol code in the core networking subsystem. It fixes a trivially exploitable use after free vulnerability. If you can run code on the system, you can get root with this particular vulnerability, which frees memory that is still being used. Okay, this problem was fixed in 2007. This is a patch for a trivial use after free vulnerability in the DCCP protocol code. Okay, now if you look at this, it looks like a very similar patch, a very similar vulnerability. And in fact, if you look even closer, see the original patch was in TCP receive state process. The other one was in a function called DCCP receive state process. One was clearly cut and pasted from the other. Okay, and in fact, it makes sense. If you're implementing a new protocol, you start with working protocol code and then change it to work the way that you need it to work. This latter trivial use after free vulnerability was fixed about 2 weeks ago. Okay, we had the first one that exhibited a pattern of a way that things can go wrong. We had code that was copied and pasted from the vulnerable code, and nobody went and looked at that copied and pasted code or looked for another occurrence of that pattern to see if we had other vulnerabilities like it. And so as a result, we kept a trivially exploitable vulnerability in the kernel for 10 years longer than we needed to keep it there. We have nobody looking for patterns like this, and I believe this particular pattern probably exists in other places in the networking code. It's a result of a questionable API choice that was made over 20 years ago that we've never fixed. I wish that I could say I thought that the attacker community was equally under-resourced in terms of looking for things like this, but I don't believe that for a second. I would not be surprised to learn this vulnerability had been known for years in the attacker community. So we have a lot of this kind of stuff that nobody is really looking for. It shows up at all levels. This is just an article I stumbled across as I was putting together this talk, talking about vulnerabilities in automotive applications in cars and such. These vulnerabilities get out into places where they really matter, where they really affect our users. So to my mind, security shows a big hole in our maintainer model. This is a place where we haven't really scaled properly thus far. And there are consequences that come from it. And as the community gets bigger, as the kernel gets bigger and more complex, this is going to continue to bite us harder unless we find a way to do something about it and to support parts of the kernel that are not, in my mind, sufficiently well supported. So get into other things, but I want to step back for a minute and think a little bit about what the maintainer model is in general and how we approach it. So we can start with a simple question. If somebody wants to become a subsystem maintainer, what do they do? How do they get there? Well, we've never defined that. And so I ended up resorting to this. Neil Brown, being one of the most quotable of all kernel developers, said that the way that you become a maintainer is by failing your first test. Because a maintainer's job is to say no to things, to keep things out of the kernel that don't belong there. But the way you become a maintainer is by failing to say no to the maintainer role when it becomes thrust upon you. And so by definition, our maintainers are not qualified for the job. More seriously, if we have an ambitious developer who wants to take on this role, we can't tell them what to do. There's no real process or way for this to come about. And it's tied to the related question of how do you stop becoming a maintainer? So Neil again, when he got tired of it, saying his approach was to try to appear to be an incompetent maintainer so that somebody would offer to take over the job. As he put it, it isn't working yet. Anybody who has watched the process for a period of time knows that this generally does not work, that it takes a very long time for somebody who is not doing the maintainer job well to be sort of eased out of that role. Mostly because people understand that it is a difficult and stressful role, and the only way to ease somebody out is usually to offer to take it over yourself, and people often don't want to do that. So what Neil ended up doing was simply leaving, and leaving a vacuum there, and leaving his subsystem unmaintained for some time because there was really nothing else that he could do. This, of course, is something that subsystem maintainers are generally unwilling to do because this is code they've been caring for years, and they don't want to leave it unmaintained like that. And this leads to all kinds of trouble. A classic example in my mind is the wireless networking subsystem, the wireless networking drivers. 10 years or so ago, our wireless drivers were in a pretty poor condition. We had a bunch of drivers with no real framework. They didn't always work all that well. We had a maintainer who came in and oversaw the conversion to a proper framework and what is now a pretty good, well-running wireless networking subsystem. But over the course of this, he really burned himself out and got very tired of it and let it be known that he thought he was done. He had done his job, and he would like somebody else to take this over. It took about 2 years to find somebody else who was willing to take on that role, during which time he had to continue to do this, even though he really didn't want to anymore. And wireless networking development suffered as a result of that. This is something that happens a lot. We tend to run our maintainers into the ground, and we don't have relief for them when the time comes for them to move on. And I think that hurts us, and I think it will continue to hurt us as we try to grow our development community. Once you become a maintainer, what's your authority? I found an interesting quote giving one view of this, a fairly typical view, which is Greg Crow-Hartman saying that kernel maintainership is not a no one else can ever touch this style of development. Kernel maintainers do not have absolute control over their particular subsystem. And as I said, this is how I think a lot of us have viewed the task for a long time, but not everybody sees it that way. And so we had a fairly well-known developer in this community saying that it's his prerogative to say no to anything in Arch/ARM, and he really doesn't have to give his reasons for it if he doesn't want to. Now, one might argue that this particular maintainer is an outlier, but the simple truth of the matter is that's not entirely true. There are an awful lot of maintainers who maintain a pretty firm grip over their subsystem, and it's their turf, and they want to hold on to it. Again, in Australia, I was talking to a fairly well-known developer familiar to many of you, and he described the current state of the kernel community as a bunch of little fiefdoms. A lot of people running their own little part of the kernel, running it their own way for their own purposes, and not always seeing themselves as part of a bigger whole. And we see this in a lot of different ways, from people saying, you cannot touch my subsystem at all, to kernel subsystems that have their own rules for comment styles. There's a particular large subsystem that you cannot get a patch into if you have not arranged your variable declarations in reverse Christmas tree order. Okay, look that up if you don't know what that is. There are people who have very firm rules about how you do subject lines. There are different rules about how you, say, handle stable patches, that sort of thing. Every subsystem is a little different. Every maintainer is a little different. It makes it hard for developers to know how to contribute to a specific subsystem without getting into trouble. And I think that once again, as our community grows, the more that we have little fiefdoms, the harder it's going to be to maintain the kernel as a single coherent project. And I think that that's a problem that we need to be facing. Related to this, what are a maintainer's responsibilities? What is a maintainer supposed to do? Greg, again here, exhibiting one aspect of it when he said, I can't take patches without a changelog text, and neither should any other maintainer. This reflects a fairly common expectation of kernel maintainers, that we want good changelogs for our kernel patches. And so if a patch does not meet that standard, the maintainer should not accept it. But as we see, we don't have a consensus even on this because there are over 500 patches merged into 4.10 with no changelog at all. So we don't really have a sense for what that rule is. We've never really codified a maintainer's responsibilities in general. There are a lot of things that we think that a maintainer should be doing, starting with things like reviewing code, mentoring developers, responding quickly to patches, telling developers what the status is, ensuring the provenance of our code. We don't want people contributing code to the kernel that is not legitimately contributed, sort of thing, dealing with regressions, getting fixes into stable, representing the subsystem to the world, the companies that are involved with it and so on, is definitely a part of a maintainer's job. And resisting pressure from companies to get stuff in, which is something that some maintainers have to deal with a fair amount of. And of course, the one unavoidable task of any kernel maintainer, which is to keep Linux happy. And this is often where maintainers tend to go wrong, especially when they're new, because we haven't really documented the rules for keeping Linux happy either. And so if you fail there, you hear about it. And this tends to be not a good experience for people trying to move into the maintainer role. Even at the mechanical level, you think about the management of patches, which is a big part of a maintainer's job. Making sure they don't fall through the cracks, maintaining your Git repository. This is another place where maintainers often go wrong early on, is failing to manage their repository in the right way. And then you definitely hear from Linux. Informing contributors, all this sort of stuff is all a bunch of low-level mechanics that every maintainer has to do, but each one of us has our own scripts, our own practices, our own policies, and there's not much cooperation, not much common structure there. And again, it makes it hard to keep the kernel as a coherent project, and I think will become more so as we try to grow. And while I'm on the topic of patch management, we have, over the years, developed a pretty well-tuned process around mailing lists and email and Git and all that sort of stuff. And it works very well for us. It is scaled very well. But at some point, we are going to have to face the fact that kids these days look at things a little bit differently. And to many of the people who are coming into their own as developers, things like email are how you get a message to your grandparents. And they're just appalled at how primitive our process looks. So the problem, of course, is that the way that a lot of these developers like to do things with GitHub pull requests and so on doesn't scale to our volume of work at all. So the tools that are out there, the new tools, don't really work for us. But at some point, I think we're going to have to face this. We've had a number of scalability issues that have involved the development of new tools over the years. Some of us, like the development of Git, have changed the world in the process. I think we may have to do this again sometime in the near future to move the development model into the way that the people expect it to be in the upcoming world, while not sacrificing the ability to deal with patches by the thousand, as we do now. And we're going to have to face this because our community is getting older. This is a picture of a whole bunch of current kernel subsystem maintainers. But I took this picture at the very first kernel summit in 2001. Sometimes you might say that the only thing that has changed is that there's less hair and less Eric Raymond. But otherwise, an awful lot of these people are still around, a lot of the same people. Some of them, as far as I can tell, are still wearing the same clothes. But you know, one aspect of this is that much of the upper levels of our maintainership structure are occupied by the people who first got into this in the 1990s. And that's a good thing. That's a body of experience that helps keep the project going, and we desperately need. On the other hand, more and more of these folks are going to start finding other things to do with their lives. And we're going to have to replace them. We're going to have to bring in an awful lot of new maintainers, I think, at some point, as these people move on to other things. So at this point, it's going to bite us that we don't define the maintainer role very well. We don't document how to fill it. And we really don't train or mentor our future maintainers. And I think this is going to affect the ability of our community to scale as we go forward. It's something that I think we're really going to have to address in the coming years. A couple other things worth mentioning here. One is code review. We have a rule that says that code doesn't get into the kernel if it hasn't been reviewed. Here's a quote from Greg saying, the big problem is we only have a very small group of people reviewing code in the kernel. He said this in 2006. But I don't think many people would say that the problem has gotten better since then. In fact, we have a fair number of people saying that it has gotten worse. Mikhail Hako, a memory management developer, posted this just a couple months ago, saying the number of patches posted grows over time while the number of reviewers is not scaling with the number of patches. Another developer familiar to many of you, Wolfram Song, gave a talk a few months ago where he made pretty much the same point, that the number of reviewers is not scaling with the number of contributors. He has a bunch of metrics to back this up. He's looked at things like the time that passes between when a patch is first posted and when it is actually merged into a repository for moving upstream. And that time, he says, is growing. The time it takes us to actually get through the review process and get a patch merged is growing. So if you look at the development process, one might argue that our throughput is increasing as the number of patches we merge is increasing, but our latency is also increasing. And that, I think, is going to hurt us over time. So as the number of viewers does not scale with the number of contributors, there are consequences with maintainers burning out and falling behind, because if nobody else reviews code, then the maintainer has to review it. All right? No one, because the maintainer is not supposed to merge code that is unreviewed. So if no one has done it, it's up to the maintainer. And maintainers get very tired and burn out, they fall behind, and so they either just don't do it and they drop patches on the floor, or else they just sort of merge it anyway and hope for the best. And we see a certain amount of that going on. This is an amusing quote from Thomas a little while back, actually just a few weeks ago. He was seriously grumpy about this engineering train wreck, had 7 signed off buys from company developers for 50 lines of code, and none of them figured out that it was broken. So even when we ostensibly have review, we don't necessarily have good code review that is going on. And I think we've all seen examples of code that really should not have been merged, but we don't have the review resources to keep up with it. Another consequence of this can be API issues. In 4.10, we just about released the 4.10 kernel with a problem in a new feature, which allows the attachment of a BPF program to a control group to filter network packets. There were some API issues there that could have led to some fairly serious security issues that, if they had not been fixed before 4.10 was released, would have been unfixable afterwards, at least without breaking API compatibility, which is something we're very, very reluctant to do. So this is only found because we have a particular very persistent reviewer who insisted that it be fixed. We have released many APIs over the years that have not seen this kind of review, and so we're carrying a lot of problems as a result of that. This leads to more long-term maintenance issues and makes things more difficult in general. Review bandwidth, of course, is not a problem that is unique to the kernel. It is endemic to any project out there that cares about code review. But it is certainly acute for us, and it appears to be getting worse as the community grows. The reviewing is not scaling with it. So I might make the point that we work very hard to encourage contributions. We aren't working so hard to encourage review. And perhaps we really should be doing more to promote the development and use of code review skills. All right, it wouldn't be one of my talks if I didn't bug people about this. Here is a slide that Tim Bird put up at a kernel summit a couple of years ago, just listing the amount of out-of-tree code that was shipped with a number of popular phone handsets. And so the numbers are all in the millions of lines of code. One might argue that after all the unused code is configured out of a kernel, there's more out-of-tree code being shipped in these handsets than mainline code. I don't really have to tell this crowd about this. You all understand very well, I think, how this particular part of our ecosystem works. And I think you understand the consequences that come from it as well. We have bugs and security issues from all these essentially unreviewed kernels being shipped out there. The inability to run mainline kernels on popular hardware out there, which is hard for developers, hard for people trying to get into our community. Stress on maintainers trying to balance in and out of tree users, and the fact that the people maintaining all this out-of-tree code are not working in our community, and that weakens our community. We lose a lot of talented people who I think would be better off supporting our community. So, and this brings about other problems like the same sorts of upgrade issues I mentioned before. In fact, if you think about this slide that I put up back at the beginning of the talk, about 2 or 3 years between releases and difficult upgrades and so on, and then you look at my handset, my current phone, running current Android. It has a 3.10.73 kernel on it. This is a kernel that was released many years ago. This kernel is 250,000 changes behind the mainline at this point. But that's what's running on my current Android phone. So this all starts to look very familiar. We've seen this before. Right? We've seen where we can't upgrade, and so we're just backporting all this crap into our older kernels. And it bit us badly back then, 15 years ago. And I think it's likely to bite us badly again now. So I think we really have to ask, how much more can we scale when there's so much that's going on outside of our community instead of within it? Where we're not really growing our community as such as growing the out-of-tree part of it. This problem is bad. It seems to be getting worse. And I think that it's something that hopefully this crowd, as much as anybody, can hope to address over the years and try to fix. And I know you're all aware of it, but I have to harp on it anyway. All right, last concern I'm going to just mention quickly is the complexity of the kernel. How many of you understand the read, copy, update subsystem in the kernel? A couple of wavy hands. How many of you would be willing to try to change it? Right, we have one developer who understands read, copy, update. We have maybe two who are willing to go and make changes to the footex subsystem. We have probably one or maybe two who understand how path name lookup works in the virtual file system layer. This is all incredibly complex code, quite difficult to follow. And we have very few people who understand it. Now, we have plenty of people, I think, who are capable of understanding it if they apply their talents to it. We have nobody who could step in and pick it up quickly if the need were to arise. As these developers get older and think about doing other things, we're going to have to pass this code off to other people. And it's not entirely clear how we're going to do that because we are not really bringing up new maintainers for these subsystems. So it's going to be an interesting issue of how we pass this code on. We'll figure it out, but it's a problem that I think needs to be on our radar, because the complexity of kernel code has grown significantly over years, and parts of it are indeed quite difficult to understand. So just to sort of close things out here with a few ideas for what we can maybe try to do about all of this stuff. One, I think, is that we need to better recognize maintainership as an activity that needs support within our community for our maintainers, needs support within the commercial ecosystem, so that maintainers actually have time to be maintainers. And perhaps support from more of the companies out there, understanding that it is in their interests to support maintainers for the core kernel, for the whole kernel, because we're all dependent on it in the end. We need to keep this part of our system just as healthy as we need to keep the contributor base. This is just an important part of the whole thing. As part of that, we need to, say, harass the documentation maintainer to document what it means to be a maintainer, because we don't have that. There's nothing out there that says, if I want to be a maintainer, this is what we have to do. It's not there. It's all in people's heads. It's sort of developed over time, but it's never really been set down. And I think it's maybe coming to time where we need to do that. And associated with that is to create training and mentoring for new maintainers so that we can try to bring maintainers into our community. We don't have that. One way that I think would help that and would solve a lot of other problems as well is to try to move away from the single maintainer model. Most of our subsystems have one person who maintains them, one person whose job it is to merge patches, send them upstream, and so on. That focuses an awful lot of stress on a single person. If we can move a little bit more towards group maintainership models, where we have multiple people there, then we can spread that stress, where maintainers can actually take vacations during the merge window and not find their inbox on fire when they come back. And also where we can train new maintainers, part of this whole group maintainer model. I think that Arndt and Olaf have done a great job of showing how this can work with the ARM sock tree, actually. I really like what Daniel Vetter is doing with his graphics driver subsystem, where there's now over a dozen people who are empowered to commit to that repository. So we have a whole large crowd of people who are learning how to maintain that subsystem and who will be ready to move on to bigger things when we need maintainers elsewhere in the kernel. I think we need to do a whole lot more of that and change our maintainer model in that way to try to bring that about. We need to teach people how to review code. We don't have a guide that says, here's the things to look for when we're reviewing code. And so every code reviewer looks for their own things. So we have some people who are very good at reviewing code for locking problems. There are other people who are very good at looking for, I don't know, stack usage or security issues or ABI issues, that sort of thing. We have a fair crowd of people who are very good at reviewing code for white space issues. But we do not have anything that says, here are the things you should be looking for in kernel code to make sure that that code doesn't go in with known sorts of problems. We have some tools. Our tooling is getting a little bit better, but we could do a whole lot better in terms of training our reviewers, and more to the point of encouraging people to use those skills and giving them time to review code out there. Code review takes a lot of time. It's a lot of work. It's hard work. It's well known that code reviewers tend to get really grumpy because they tend to be overworked and doing it on time when they're not doing everything else. If we gave them more time, we would have better code review. And in my experience, there's also no better way to learn about how parts of the kernel work than to review patches going into it. Because by the time you get to where you can ask educated questions about the code, you've had to understand and learn a whole lot of things. So if more people spent more time this way, we would have better kernel developers in general. Pay more attention to our unmaintained dark corners. We have large areas of the kernel that aren't really being looked after the way they should be. And I think that that's not going to scale well as we grow bigger and the nasties in those bits of code come out to bite us. Thinking about tools, as I said, because I think we need to figure out what our next generation of tooling is going to look like so that we can start to work on developing it. And just to close it out, we've been a good 10 years or so without a real scalability crisis. We've had a really good run since we made the changes I described back at the beginning of the talk. So it might be tempting to believe that we've solved our problems and we're good. We're going great for now. I want to challenge the assumption that we're done with our scalability issues, our process scalability issues. And we need to be looking forward to what the next ones are going to be. We've solved all of them in the past and come out much stronger for them. We will solve any future ones as well. I'm not worried about that. But if we can think about them and start thinking about how we're going to solve them now, then I think we will have an easier time and go through rather less drama in the coming years than we might otherwise do. So I would like to encourage us to do that. And on that note, I am done. And I would like to thank you all for your attention.
Okay, thank you so much, Jonathan. That was really interesting, and certainly you hit a lot of topics that are regular topics inside Linaro. And does anybody have any questions before we have a few minutes? Are there any questions for Jonathan?
So one of the topics we've been talking about this week is kernel functional tests. You know, on desktop systems and even server systems, there's a lot of people that get, the kernel code gets tested in those environments. Some of these more specialized environments like embedded systems and cell phones and things, it's hard to get real timely feedback on problems and things like that. So, you know, we're trying to work on that problem. I just wondered if you had thoughts on that.
Well, yeah, testing has been a perennial issue for the kernel. For a long time, we used to say that to justify our lack of tests by saying that most of our problems are workload and hardware related, so we couldn't test them anyway, and that was what we kept users around for. And, but in fact, that's kind of a lame excuse for a lot of things. So I think we are getting better with our testing picture in a whole lot of ways. We have just the embryonic set of self-tests in the kernel now. It's just the beginning. We have a long way to go with that. We have efforts like kernel CI. We have efforts like the zero-day tester out there that have improved our testing in that regard. So I think that our story is getting better, but we have a long way to go for testing. And I think that is, in fact, it's an area I didn't touch on, but to scale our process going forward, we have to find more problems before they go out and bite users. And so I agree that we very much need to improve our testing. And I'm encouraged by what we see, but we're just beginning.
Okay. Anyone else? Any other questions?
Hi. You just mentioned that reviewing the code is very important, but still there is a challenge in getting the SOC vendors opening their data sheets or getting the specifications out in public in time when the code is getting populated in the kernel tree. and it has been a challenge for many years. So is there anything that is being done to motivate the SOC vendors and the spec maintainers to release the specs and SOC data sheets?
Well, yeah, getting information out of hardware vendors, of course, has been a problem since the very first days of kernel development. And at the SOC level and all that stuff, it is a problem. And there are plenty of things being done in terms of trying to push vendors to release their information, trying to get vendors to work more directly upstream as opposed to shipping their own vendor trees with a lot of backported code, that sort of stuff. But what really solved it in the end in the server side of the ecosystem was when the customers started demanding upstream code. And I think that's perhaps what's really required at this level of things as well. And we haven't seen that yet, but I keep hoping that it will happen. When that happens, when the customers really require it, then the vendors will respond.
Okay, any others? Any other questions? So the out-of-tree code thing comes up for us all the time. I mean, it's a pretty regular topic of discussion. So do you have perspective on, well, so what is good hygiene? Would you ever expect it to be everything to be upstream? I mean, what's the metric here, really?
Well, everything upstream is a difficult to attain ideal, right? But I think it's what we should be aiming for, and the closer we can get to it, the better we are, because when code is upstream, it works better, right?
Well, so are there any phones or companies that you could point out today that you think are, you pointed out a number that you felt that there were a lot that had a lot of lines of upstream code. Are there any that you think fit better into the more positive metric there?
At that end of the ecosystem, it's pretty hard at this point. So I'm not sure I want to call out any particular vendors at this point. You see improvements here and then regressions there. So
we have a lot of work to do as an industry.
We have a lot of work to do.
Right. All right, well, thank you so much today for coming here and sharing all that with us. We really appreciate it.
Well, thank you all.
Okay, so that's a wrap. We'll start the sessions at 10 this morning and be back in here at noon for the close-up, and then we'll go in to have some lunch and demo for